Hello and welcome back to Math with Mrs. Becker. Today in Algebra 2, we are going to hammer through section 3.3. I hope you guys are ready for some fun. When a problem uses phrases like greater than, less than, no more than, you can model the situation using a system of linear inequalities. So remember, in order to have a system, that means you have to have at least two. In this case, it's going to be inequalities, meaning greater than symbol, less than, greater than or equal to, less than or equal to. A system of linear inequalities is a set of two or more linear inequalities that have the same variables. Okay, so in our case, our variables, at least at the beginning, are going to have x's and y's. The solution to a system of inequalities is often an infinite set of points, meaning our solution we will be shading. So we're doing the whole test point thing. What side do you shade? However, because it's a system, we have to do that more than one time. And where all of those shadings overlap, that is going to be your solution. So you guys, this is so fun. When you graph the multiple inequalities on the same graph, where the shadings overlap, that's your solution. So our solutions are not going to be numerical. You get to color in the graph, and whatever's colored in, that is your answer. Let's do this. Okay, here's the first one. So I do have y all by itself. Okay, so this is in the form y equals mx plus b. After the x is a -3. So if I go down 3, the slope is 1 over 2. So I go up 1 over 2, up 1 over 2. Because it's an inequality, I have to check and say, okay, is this a solid or a dotted line? This would be a dotted line, and we just did this. Okay, we did this in our previous chapter. What's going to be different, though, is now we have to have more than one. Now I need to figure out, okay, from this line, is this region true or is this region true? Because remember, we always shade the true region. So what I need to do is use a test point. And a test point is any point that is not on the line. So I'm going to go ahead and I'm going to test 0, 0. What that means is I can change the x and the y value in this inequality into a 0. So y becomes 0 is less than 1/2 times x, which is 0. 1/2 times 0 is 0. 0 minus 3 is -3. So my statement says that 0 is smaller than -3. Well, that statement is false. That means that 0, 0 is in the false side. So we always shade what is true. So if 0, 0 is false, that means this side is true. Okay, now I go to the second one. Y is by itself. I go up 2. -1 is the slope, so down 1 over 1, down 1 over 1. Now when I go to connect, I have to see if it's a solid or a dotted line. This, my friends, would be a solid line because it includes the value. Now I need to see from this line, do I shade this way or do I shade this way? So now I need a test point from my second line. Again, 0, 0 is not on the line, so I can go into this inequality, change the y to a 0, and change the x to a 0. Well, -0 is just a 0. 0 plus 2 is 2. So I end up with the statement that 0 is greater than or equal to 2. That is a false statement. 0 is not bigger than 2, so that means 0, 0 falls on the false side. So when I go ahead and I shade, I need to shade the true side, which is the side that does not have 0, 0. Okay, so I go ahead and from this line, this is where I shade. Now your solution, you guys, your solution is where you end up shading both. So if I look, this region right here, this is where I ended up shading both blue and orange. So I make this darker, or you can use a different color or something where it stands out. This region is our solution. And what this means is any point that's within this region, you could take those ordered pairs, fill them into the top inequality, it would make it true. Fill it into the bottom equality, it would make it true. So this is what our assignment looks like today. So fun. Let's keep going. Okay. The first one, again, y is by itself, so whatever's after x, That's your starting point. So I go up 2. -3 is your slope. So it's down 1, 2, 3, go to the right 1. When I go to connect the line, I have to see if it's solid or dotted. This would be a dotted line because the value would be an open circle on a number line. Now I need to do a test point. 0, 0 is not on the line. So if I test 0, 0, y becomes a 0, less than -3 times 0 is 0. 0 plus 2 is 2. So my statement says 0 is smaller than 2. Hey, that is true. So what that means is that the side that has 0, 0, that is the true side. So I shade this side of my dotted line. Now I go to the next inequality. I only have one variable. If you only have one variable, that means that your line will either be horizontal or vertical. In this case, it's going to be horizontal because it has to cut the y-axis. It cuts the y-axis at -1. Y runs up and down. So I go down 1. This will be a solid line. I need a solid line that cuts through the y-axis at -1. I still do a test point. Even though my inequality only has one variable, you still have to pick a point. 0, 0 is not on the line. What this means is any x's and y's, I can change them to 0. I don't have any x's, so I just don't have to worry about it. But y still becomes a 0. Is 0 greater than or equal to -1? And again, if you are somebody who struggles with negative numbers, think about temperature. Is 0 warmer than -1? Well, heck yeah, it is. That is true. So that means that I do shade the side that has 0, 0. I shade above that line. So our final answer, you look and say, okay, where did I shade both places or both times? This region right here. So you would do something whether you take a highlighter or you take a different color or you just make it darker, but make sure that I can look and I would know exactly where your solution is. So in this graph, this region right here, that is our final solution. I know some of you guys are having fun. I can tell, even though I'm, not with you. Okay, let's look at the next one. Remember, you can graph using intercepts. So if I look at both of these inequalities, they are in that standard form where it's like ax plus by equals c. Your x and your y are on the same side. So one of the easier ways to graph them is to do intercepts. Remember, that means that you fill in a 0 for the x, solve for y. Then you fill in a 0 for the y and solve for x. So as we're doing this, just pretend like this is an equals, just to help us find that value. So if I fill in a 0 for x, the x would cancel. If this was an equals, if I wanted y by itself, because that's what I'm trying to find is the y value, I'd have to divide by -3. +6 divided by -3 is a -2. So 0, -2 is a point. Now, if I put in a 0 for y, -3 times y, if that's a 0, -3 times 0 becomes 0. So that cancels. What I have left is just an x and a 6. So if I go to the right, 6, I stay at 0. Now I look, would this be a solid or a dotted line? Well, it would be a dotted line. Okay, there we go. Now we have to do a test point. Again, 0, 0 is not on the line, so I'm going to test 0, 0. That means that I can go here and I can change both the x and the y to 0. So x would become a 0, -3 times y. Y is a 0, so that's 0. 0 minus 0 is 0, so 0 is less than 6. Well, yeah, 0 is less than 6. So that means that the side that has 0, 0 is the true side. We always shade the true side. And we're done with that one. Okay, now the next one, I do have x and y on the same side again. So let's just go ahead and do intercepts for this whole problem. If I put in a 0 for x, then I put in a 0 for y. If I fill in a 0 for x, 2 times x would become 0, leaving me just y is 1.5. So I stay at 0, I go up 1.5, there is a point. If I put in a 0 for y, what I have is 2x equals 1.5. Well, if I take 1.5 and I divide it by 2, you get 0.75. So I go to the right almost a whole unit, and that's where I'm at 0. So that's where that line would be. This also is a dotted line. Remember, these are boundary lines. You have to make sure you go all the way through the graph. Now, from this line, I need to see which side is true. Do I shade here or do I shade here? 0, 0 again is not on the line, so I'm going to test 0, 0. What that means is I go into the bottom equation, I change the x to a 0, and I change the y to a 0. This becomes 0, this becomes 0. My statement would read 0 is greater than 1.5. Yeah, I don't think so. That is a false statement. 0 is not bigger than 1.5, so that means 0, 0 is in the false side. You always shade the true side, so I would shade the other side from this line. So your final answer, you look and say, all right, where did I shade everything? Right here. This would be your final answer, right there. That region where you ended up shading for both of these inequalities. Guess what? We can do this with 3. Oh, I hope you're ready for some fun now. This is getting wild. One value. If I only have one x or one y, that means my line has to be horizontal or vertical. In this case, it's a vertical line because we're cutting the x-axis at 6. The x-axis goes left to right. This is a positive 6, so I go right 1, 2, 3, 4, 5, 6. This is a solid line that has to cut through the x-axis. Now what I need to do is go ahead and do a test point. If I test 0, 0, I would change any variable into a 0, making this 0 is less than or equal to 6. Well, yes it is. 0 is less than 6, so I would shade the side that contains 0. So right now, I know that my final answer has to fall on this side of the vertical line. Now I go to the next inequality. Y is by itself. The value after x is plus 1. Notice we're going by 2's here. So if this is 2, I have to go up 1, which is halfway there. Then I go up 1 over 2, up 1 over 2. This would be a solid line. My points didn't line up very good, but we got this. Go ahead, go all the way through. Now I need to figure out where I shade from there. Again, 0, 0 is not on the line. It's pretty darn close, but it's not there. So if I test 0, 0, I have 0 is less than or equal to 1/2 times 0 is 0. 0 plus 1 is 1. So the statement says 0 is less than or equal to 1. Well, yep, that is also true. So I go ahead and I shade the side that has 0, 0. But I'm not done yet because we have one more inequality. So right now I know my final answer has to be somewhere within this region. One more to go. Y is by itself, so I go up 4. The slope is -2, so I go down 2 over 1, down 2 over 1. This is a filled in line, so it's a solid line because on a number line you would put a filled in circle with that symbol. Now what I need to do is say, okay, from here, do I shade this way or do I shade this way? I'm going to go ahead and test 0, 0 because again, it's not on the line. If I change y to a 0 and I change x to a 0, this would become 0. 0 plus 4 is 4. Well, is 0 greater than 4? Nope, so that's false. So from this line, my most previous line, 0, 0 is the false side. So that means that this side is the true side. Here's the really cool thing. Sometimes what happens when you go ahead and shade, the place where I did all of the shading, we end up with a figure. Okay, and that's what this says, is it says classify the figure. And really, that's not like part of the assignment. They just want you to realize that sometimes when you go ahead and do the shading, you get a shape. So when it says classify the figure, you're just like, whoa, I got a triangle, cool. Okay, they want you to get excited about it. The main thing is, this is your solution. All right, let's keep on going. Oh, we're stepping it up. We got like the varsity graphing now, okay? Here we go. I'm grabbing more colored pencils. This is gonna be wild. We have 4 of them, you guys, 4. All right, so if I look at the first one, I have to cut the x-axis, which runs left and right, -2, so I go the left 2, solid line. There is the first one. Now, if I do a test point, I am testing 0, 0. This would say 0 is greater than -2. Yeah, it is. 0 is, thinking of those temperatures, 0 is warmer than -2. So that means 0, 0 is on the true side. So from this line, my final answer has to fall within this region. I really hope you guys are having fun coloring with me. This is awesome. Okay, next one. I have to cut the x-axis. X runs side to side. +3, so I go to the right. 1, 2, 3. And I'm cutting the x-axis, so it's a vertical line. This would be a solid line. There we go, there we go. Now I got to see, where would I shade? Do I go this way or do I go this way? If I test 0, 0, the x would become a 0. My statement would be 0 is less than or equal to 3. Yep, that's true. So from the green line, I have to shade the side that has 0, 0. So right now, what we know for sure is that our solution has to fall within those parallel lines, because they are two parallel lines. That's awesome. Let's go ahead and look at the next one. Y is by itself, so I need to go up 1. My slope is -1, so down 1, over 1, down 1, over 1. Solid line. Yes. You guys, this is so fun for me. I hope you're having fun too. This is good stuff. Okay, now I need to figure out where the heck do I shade this orange. So I can test 0, 0. If I test 0, 0, I have the statement 0 is greater than or equal to. -0 is 0. 0 plus 1 is 1. Is 0 greater than 1? That's false. So from here, I have to shade the side that does not have 0, 0. So right now, I know that my solution has to be within this region, within those two vertical lines and above the diagonal line. One more line to go. Y, I have to cut the y-axis, so it's going to be a horizontal line. Y runs up and down. This is positive, so I go up 4. Again, we have another solid line. So if I go ahead and look at this, I need to know, do I shade up or do I shade down? So if I test 0, 0, I would put a 0 in for y and go ahead and have 0 is less than or equal to 4. That is true, so we shade below that line. So our final solution is where we shaded every time. So we know it has to be in between the parallel lines. It has to be above the orange and below the brown. So here is my shape. And you guys, guess what? This is called a trapezoid. It's a trapezoid because these two sides are parallel. So these are called the bases, the two parallel sides. So you guys, we made another shape. We made a trapezoid by solving this system of inequalities. Super fun. This is your final solution. Okay, now looking at time, I do want to keep these Zoom meetings about 20-25 minutes so it doesn't get too lengthy. So we are going to skip this one. If you want to go ahead and watch another one with 4, you could hit rewind and watch this again. But I do want to be, I want to make sure that you're not staring at a screen for too awful long, okay? Let's go ahead and look at some story problems, because it is important to realize, all right, yeah, this is cool, Becker, and we're coloring, and yay, good times. But when would I ever actually use this? Well, there's a couple scenarios here that we can look at. Lauren wants to paint no more than 70 plates for the art show. Okay, so Lauren is going to make plates for the art show. She wants to make no more than 70. What that means is she'll make any number up to 70, but she's not going over that, okay? It costs her at least $50 plus $2 per item to produce red plates, $3 per item to produce gold plates. She wants to spend no more than $215. So she's okay spending $215, but not going any more than that. Write and graph a system of inequalities that Lauren could use to figure out the number of plate combinations that she could make. So again, this is a system because you guys were looking at two different things. Let's say that X is red plates, and let's say that Y is gold plates. And I totally just realized I'm using colored pencils. Okay, so red is going to be X, Y is going to be gold. Well, here's the first thing. Lauren is doing red plates plus gold plates. This is the amount of plates. She wants this no more than 70. So she wants this amount to be less than or equal to 70. She's okay if it's less, she's okay if it's 70, but this cannot be more. So X plus Y is less than or equal to 70. Now your second thing that we're looking at is money. It costs her $50 no matter what. The cost is $50 plus $2 for red plates, so 2X, plus $3 for gold plates, so 3Y. She wants to spend no more. This is her cost. No more than, so less than or equal to $215. She wants the cost. It's okay if it equals 215. It's okay if it's less, but can't be more than that. Well, the first thing that I see here is I want to go ahead and move this 50 to the other side. So I would have 2x plus 3y is less than or equal to. If I take 215 and I go ahead and I minus 50, I'd have 165. Now I can go ahead and graph. This is the inequality I'm going to use. So I have two inequalities that I need to graph. If I do intercepts, if I put in a 0 for x and a 0 for y, this might be the quickest. If I put in a 0 for x, y would be 70. If I put in a 0 for y, x would be 70. So 0, 70, 70, 0. This would be a solid line. If I do a test point, let's test 0, 0. 0 plus 0, I would have 0 is less than or equal to 70. That is true. So what this tells me is if I was only focused on the number of plates, any combinations that Lauren had within this region, she knows that she would be making 70 plates or less. But she's actually looking at two things, not just the number of plates. She's worried about how much money she's spending. So let's go ahead again and do intercepts. If I put in a 0 for x, I would have to divide the 3 over. 165 divided by 3 is 55. So 0, 55 is a point. If I put in a 0 for y, I would have 165 divided by 2 because I'd have to divide that 2 over, and I would have 82.5. So if I go 82, here's 80, so 82.5 is going to be a little bit here. Go ahead and make the line. This would be a solid line. Now this is focusing on the money aspect. So from this line, do I shade this way or do I shade this way? So I have to go ahead and do a test point. Again, I can try 0, 0. If I put in a 0 for x and a 0 for y, my statement is 0 is less than or equal to 165. Well, yeah, sure, you betcha. That is. So from this line, I shade on this side. So the solution for Lauren, what she would want to do to make sure that she stays at 70 plates or less and $215 or less, she would want to stay with any of these options within this region right here. Okay, so let's go ahead and shade it because this is your solution. Now, if you were Lauren, you could use this region to figure out how many plates you're actually going to make. You just want to make sure that it falls within here. So she could do 50 red plates and no gold plates. She could do 50 red plates and 10. She could do 10 red plates and 40 gold plates. As long as the ordered pair falls within this solution region, it would ensure that Lauren is making 70 or less plates and spending $215 or less dollars. Super cool. Okay, one more question, guys. Layla is selling hot dogs and spicy sausages at the fair. Sounds like a great summer job. However, Layla, she might be in the hurt bag here. She only has 40 buns. So she can sell no more than a total of 40 hot dog and spicy sausages because she only has 40 buns. So let's go ahead and say X is hot dogs and Y is spicy sausages. Okay, so right away I realized that, okay, I do have an equation here, or an inequality. The amount of hot dogs plus the amount of sausages that Layla sells has to be less than or equal to 40, because otherwise she doesn't have enough buns. She can sell less than 40 and she can sell 40, but if she goes over, she'll have to be like, here, just hand him a hot dog, and that would be awkward. So we don't want to do that. Okay, next thing. Each hot dog sells for $2. So hot dogs are $2, plus each sausage is $2.50. Layla needs at least $90 in sales to meet her goal. So she needs this to be $90 or more because she needs at least $90. So this has to be greater than or equal to 90. Write and graph a system of inequalities that models this situation. So we got to help Layla here figure out, okay, what combinations could she go ahead and make enough money but not run out of buns? Okay, let's do the top one. If I do intercepts again, I feel like that's one of the quickest ways. If I put in a 0, y is 40. If I put in a 0 for y, x is 40. So I have 0, 40, 40, 0, filled in line. So this is just the amount that you could sell of the combinations just based off of the buns. If I test 0, 0. 0 plus 0 is 0, so my statement is 0 is less than or equal to 40. Well, yeah, that's true. So that means that Layla's got to stay for sure within this amount. Otherwise, she doesn't have enough buns. Okay, so that's the first scenario. Now she's looking at her money. Okay, she's got to make sure she has enough money. So again, I think the easiest way, because x and y are on the same side, let's go ahead and do intercepts. If I put in a 0 for x and I put in a 0 for y, let's see what happens. If I put in a 0 for x, this x term would cancel. To solve for y, I would have to divide the 250 over. 90 divided by $2.50 is 36. So 0, 36. Okay, now if I put in a 0 for y, I would have to solve for x by dividing by 2. 90 divided by 2 is 45. And now notice this is going by fives. This would be a solid line as well. Okay, so I have this. Whoa. Okay, here we go. Let's go ahead and check. I can test 0, 0. If I test 0, 0, 0, 2 times 0 is 0. 250 times 0 is 0. 0 plus 0 is 0. Is 0 greater than or equal to 90? Nope. So check this out, you guys. This is a wild question. I hope you're still on here. Okay, let's keep going. So if I shade this way because 0 was the false side, poor Layla. She is at the fair, and in order for her to not run out of buns and make enough money, here are her little slim options of what she needs to sell. This is the only little sliver on that graph where we ended up shading both ways. So she needs to sell like 10 hot dogs and 30 sausages, or she needs to sell 15 hot dogs and 25 sausages. Whatever's in this region, that's the only possible way that she's going to make enough money without selling out of buns or running out of buns. So you guys, that is 3.3. There is a quick quiz that goes with this assignment along with 1 through 10 out of your textbook on page 202. I hope you guys had a great day, and I'll talk to you soon.